In this video, we want to take a look at what we call equations that are reducible to quadratic or quadratic type equations. They have that kind of similar format in that they're a trinomial, three terms, where the exponent on the leading term is double the exponent of the middle term, and we have a constant at the end. But they're not quadratic because that leading exponent is not a 2. Still, we can use similar techniques for solving quadratics. There are two ways we can go about solving these, and I am always going to advocate to go for the easiest route. So if you can factor it as it is written, do so. Why would you do extra work? Okay, if you can't, then we'll do some substitution. So here's my first example. I have normal exponents. I have x to the fourth, x to the second. I'm going to try to factor this if I can. So when I break it down into my two parentheses, instead of starting with x and x, I'm going to start with x squared and x squared because I need to get x to the fourth in the front. That works well because then my middle terms are going to be x squared just like the problem has. Otherwise, it's factoring as normal, and we set each factor equal to 0. Where it gets a little different is when I solve that new little equation, I'm going to still have something that has an exponent on it. So in this case, if it's an x squared and I isolate it, I can take the square root, remembering that I get two answers, right? Always the positive and the negative root for my answers, and same thing over here. So when I have an x to the fourth equation, I will often end up with 4 distinct answers. That's not always the case, but that's often the case. So if you have normal looking exponents, just factor it. Just remember you have to tweak the factoring slightly. Where it gets interesting and where students begin to struggle is when we're dealing with these ones that have these weird fraction exponents or some other kind of thing like radicals in them. So let me give you this example. So I have x to the 2/3 minus 5x to the 1/3 minus 24. What I want to make sure is that this first and second exponent are double. So whatever's in the middle, I double it to get the leading term. That's going to tell me that this form will probably work. And I take whatever that variable thing is there in that middle term, and I say, let's let that be u. Some people use y, I use u. So I say u is equal to x to the 1/3. Now if I squared both sides here, using my power or rules of exponents, I would realize that u squared is equivalent to x to the 2/3. Perfect, because that's what I need for my leading term. So when you replace that middle part by u, the first part's going to be u squared. So now I have a nice normal looking quadratic equation that I can factor like normal, set the factors equal to 0, and then get my solutions. The problem is they didn't ask for u, they asked for x. So I go back and say, now what was u again? Oh yes, it's right here, x to the 1/3. So I replace the u by x to the 1/3 in both of my equations. And then I remember what we talked about in that rational exponents video, and I say, well, we'll use the power that's the reciprocal, so 3 over 1 raises to the third power. Those 1/3 times 3 multiply, give me x to the first power, and over here I just cube my answer. Same thing with this one. Now you can check these on your calculator as well. I would definitely recommend not trying to graph these because their numbers can get kind of big. You just go ahead and put them into your calculator. Let me show you real quickly how you can do that. Sorry, don't know what that was about. Let me move this over here. My calculator doesn't seem to want to work. Let's try this one more time. All right, so quit that. And what was it? X to the 2/3. Okay. So I'm going to take, let's take this 512, and I'm going to raise it to the 2/3 power. We've talked about before that if you're going to raise it to an exponent that's not just a number, you need to put that in parentheses. So parentheses 2 divided by 3, 2/3, okay, minus 5 times whatever x is. This time I'm using the 512, raised to, again, a parentheses, 1 divided by 3. And then finally minus 24. Okay, and it equals 0. And I could check the negative 27 exactly the same way. So get in the habit, check your work, don't rely on someone else or the technology to tell you if you got it right. Let me know if you have questions.